yesterday and previous days we started talking about parabolas. How do we feel about parabolas?
Pretty good.
Quadratic equations or quadratic functions make parabolas. Now the difference between what we did yesterday and what we did today is you're going to start seeing when you might have a sideways parabola. All the parabolas we've seen, they open up or they open down. If you have something like x equals y squared, instead of y equals x squared, what you're going to have is a sideways parabola. So x equals y squared makes that sideways parabola that opens to the right. And if you have x equals a negative y squared, it's going to be this parabola that opens up to the left. And one of the other things we talked about yesterday was that phrase, axis of symmetry. When we were talking about the axis of symmetry yesterday, what was that?
The line that cuts right through the
Cuts through the
vertex.
parabola. Cuts through the vertex. If we had an up and down parabola, you had a vertical line. However, if we have a sideways parabola, then you're actually going to have a horizontal line is your axis of symmetry. It's going to cut through like this. And equations of horizontal lines are going to be y equals. So your axis of symmetry is actually going to be y equals, but it's the same. It's negative b over 2a. So your axis of symmetry for a sideways parabola, it's a horizontal line that you're going to find using y equals negative b over 2a. And one of the differences between yesterday and today is, well, first it's a horizontal axis, but this is going to tell us the y coordinate of the vertex, not the x coordinate. It'll be the y coordinate of the vertex. So get that down. Negative b over 2a is big. It has to do with finding that middle part of the parabola, the axis of symmetry. All right, so let's look at our first example. I got a sideways parabola, and here's what it looks like when it pops up. You're working your problems. You probably have regular parabola, regular parabola, regular parabola, and then boom, one sideways parabola. How do you know? When it comes up, how do you know the thing on the board? Sideways. It's x equals y squared. So it's sideways. So on your four answer choices, how many do you have that are sideways? Two. That's sideways, that's sideways. Well, it will not be C or D. Those are for your regular parabolas. So a few things I want to do is I want to find out the axis of symmetry. So use negative b over 2a, which in this case, negative b is going to be negative 2 over 2a. And what's a? 1. So negative 2 over 2 times 1. Well, that's negative 2 over 2, which is what? Negative 1. So let's write the axis of symmetry right over here. The axis of symmetry, you can put it like this. The axis of symmetry is y equals negative 1. The flat line that goes through negative 1. That doesn't help us any because if you actually look, both of these have an axis of symmetry at y equals negative 1. Just like that. But what I can do is use the axis of symmetry to find the vertex. So go ahead and let's write vertex. Since the axis of symmetry said y equals negative 1, then the y part of the vertex is negative 1. How can I use this negative 1 to find the x part of the vertex?
By filling it in.
By filling it in. Going back here and changing what letter?
Y.
Yeah, change the y's on this side. So change this to negative 1 squared plus 2 times negative 1 plus 2. Remember though, if you're going to square a negative 1,
Like it.
you got to hug it in parentheses. Go ahead and do it. Take your yellow and put negative 1 squared plus 2 times negative 1 plus 2. This is going to tell you the x part. Now that is a positive 1, right?
Yeah.
So your vertex should be at right 1, down 1. Which answer shows the vertex at right 1, down 1?
B.
B does. It's right here. Now let me point out one other thing. Try to make life simpler on you. And looking at patterns and stuff for this. All right, since it's positive, I know it's going to open to the right. But do you remember what this number told us last time?
When it crosses at the y.
Yeah, it used to be.
Crosses the x.
Yeah, it used to be where it crosses the y-axis. This will tell you where that parabola is going to cross the x-axis. Out of your two answers, which show it crossing at 2?
B.
Yeah. The right answer shows that that sideways parabola actually crosses at that too, just like that. And now, let me show you one calculator trick that I came up with a few years ago to help out with this. Anytime that you have an x equals y squared equation, we have a little bit of issue with our graphing calculator in that we do not have an x equals button. You have a y equals button, but you don't have an x equals button. So the little trick that we're going to do is we're going to pretend that this is y equals x squared plus 2x plus 2. So go ahead and hit your graphing button, hit your y equals button. And put this in. Don't graph it though. Do not graph it. Just put in this as x squared plus 2x plus 2. And remember, this is a trick to figure out what the sideways parabola is going to look like. So instead of y squared, it's x squared plus 2x plus 2. Now, since this is supposed to be a sideways parabola, the trick is, whatever b is, go and change its sign. If it was a positive, go and make it a subtract. That's going to be one part of the trick. Change the b. Now, when we graph it, you won't see a sideways parabola. We are going to make it a sideways parabola by taking your calculator, rotating it 90 degrees that way. So just take your calculator, rotate it like this, and now you are looking at the graph of that sideways parabola. And look, it does cross at the 2 just like we thought it would. And the vertex is right there. So if you want to graph a sideways parabola, put it in. If it's standard form, put it in, change the b piece, and then rotate it 90 degrees. That's what we're looking at. All right, let's look at example 2. Now we know we can do it 2 different ways. We can actually graph it and look at it, kind of using this trick. So I got x equals y squared. So I got a sideways parabola. Let's see if we can find the axis of symmetry.
So wait, if b would have been a negative, you would have turned it to a positive.
Yeah, I'd flip it. I'd change it no matter what. Flip it. Okay, on this one, I got a sideways parabola, and I'll show the 4 answer choices in a second. But I want to find the axis of symmetry. It's y equals what? What's my b?
Negative b over 2a.
Yeah, negative b over 2a, so negative
2.
2 over 2 times 1. Yeah, so once again, it's negative 1. Y equals negative 1. Now that doesn't help us because that has an axis of symmetry at negative 1. And that has an axis of symmetry at negative 1. However, let's think about this. How can this help you? How can this thing help you?
Where it crosses at
Yeah.
the x.
Out of those 2 answers you had, does only one of them cross at x equals negative 1?
C.
Yeah. It's not that one. It is this one right here. So it ends up being that one. That's your sideways parabola where you cross at negative 1. And lastly, I have this right here. Now, this is a sideways parabola. This one looks kind of weird, doesn't have 3 pieces. How do I know for sure that that's a sideways parabola though?
Because it's x equals.
X equals y squared. Even if this is a 1/3 or whatever, it shouldn't mess with you. Now, which way do you expect it to open? To the right or left?
To the right.
To the right. Now, you only have 2 answers that do that, right?
A and C.
Yeah, A does it and C does it. So let's go ahead and do the calculator trick. Go ahead and put it in. Y equals, instead of 1/3 y squared, put it in as x squared. We know what it really is. Now, I would say that this does not have a B or C piece, right? The trick is that you change the B piece. If there's no B piece, well, there's nothing to change. The B is 0, and you don't have to change it. So let's graph it and rotate it. You don't have to change it. All right, so this is what we're looking at. Now, when you got to be careful here. We've got to decide if it's going to be A or C based on this.
C. You can tell because it's bigger.
What do we think?
C.
I kind of think it's A based on this. Look at here's C. When you're all the way over here at 10 on the right, you're up here at 9. You see that? And down here at negative 9. On this one, it shows you a little bit closer to 6 and negative 6. So when I'm holding it sideways, here's right 10. Where do you think this is? closer to the 6 than it is the 9, right? So that's why be careful, because there's two, they look really, really close.
So is it A?
I think it's A. I would say when you're over here to the right, this is closer to 1, 2, 3, 4, 5, closer to the 6. So actually it would be A. Just be careful about the ones that have the fraction.
Eyes are deceiving them.
Yes. But that's a basic trick to do a sideways parabola. Put it in like it looks, and what piece do we have to change?
B.
B. And then of course, rotate it 90 degrees clockwise to the right, 90 degrees. All right, that covers sideways parabolas, objective 132.